Hey everybody, in this video we're gonna take a couple minutes, like 5-10 minutes, just to cover the chain rule. Now this is especially important because when you come to a later unit and do integrals, you're gonna have to concern yourselves with this once again. So it goes both ways in derivatives as well as integrals, so you want to make sure you understand this process really well. So let's talk about what the chain rule is. Let's say you have, some sort of function, right? F of g of x. This is your function, and it asks you for the derivative of this function. So we'll call this function a of x, right? A of x is going to be equal to f of g of x. So what is a prime of x, or what is the derivative? And the chain rule gives us a formula for that, and that formula becomes f of g prime of x times, f prime of g of x times g prime of x. So this might not make a whole lot of sense at the moment, which is why I'm going to go straight ahead and show you a really quick example of the chain rule. Now, this is a pretty simple example. So let's say our function f of x is going to be equal to 5x plus 7 squared. Now, I'm using squared, well, there isn't really a specific reason, just to prove a point, I'll go ahead and change this number to 30. Now, if it were squared, you could expand 5x plus 7 squared and, take the derivative once you've expanded all the terms. But like I said, just to prove a point, if it's the 30th power, you really don't want to multiply a binomial 30 times. It's a lot of work, which is where the chain rule comes in handy. So we'll go ahead and use this formula. So there's going to be a double formula within here, right? You have to keep in mind the idea of that a to the n, the derivative of this becomes n times a to the n minus 1. So the chain rule is a combination of these two rules. Now what does this mean? Well, if we want to take the derivative of our f of x function, first we have to do this, and we'll get 30 times, we'll treat this as our a and this as our n, so we get 30 times 5x plus 7 to the 30 minus 1, which is 29. Now this is the part where the chain rule comes in handy. The chain rule states that you have to take the derivative of the inside function. You have to change you have to take the derivative of the inside function and multiply it by the derivative of the entire thing. So the derivative of our f of x function was this. Now what's the derivative of our a function? The derivative of a function is going to be just 5. So you multiply this entire thing by 5, and your final derivative of our a of x, or our f of x function in this case, is going to be 150 times 5x plus 7 to the 29th. Now basically what you're doing, you have two functions right here. And the chain rule, you're basically taking the derivative of this function and multiplying it by the derivative of this function, which is why you get f prime of g of x times g prime of x. So that's where the formula comes from. And this is one of the rules that you're going to use a lot throughout derivatives and even in integrals. And when we go to integrals, we'll go ahead and tackle that then. It becomes a little more complicated at that point. But this is the basic idea of the chain rule. So let's do some more examples. You might have a trigonometric function where you have f of x, is equal to, let's say, sine of x. Let's go sine of 2x just to make it a little more complicated. Sine of 2x to the 5th power. So what is the derivative? Well, keeping in mind this equation right here, we want to take the derivative of our entire function. So we're going to take the derivative of this entire thing, and we're going to treat sine of 2x like it's just x, right? So basically what we're doing here, we're rewriting this to be x to the 5th power. And now we're taking the derivative of this, which gets you 5x to the 4th. And once we come back here, we replace that x with sine of 2x. So we get 5 times sine of 2x to the 4th. And now, from here, what do? Well, now we treat this as a function and we take the derivative of this function. So what is the derivative of sine of 2x? Right, so in this case, you're going to have to once again use this kind of rule right here. So the derivative of sine is cosine, right? But that's the derivative of sine of x. Sine of x gets you cosine of x, right? So what does sine of 2x get you? Well, once again, you have to use the chain rule. This is a chain rule within a chain rule. So you're going to get cosine of 2x, but you're treating 2x as your inside function, right? If you put parentheses around here, this is your inside function. Taking the derivative of your inside function, you get 2. So the derivative of sine of 2x is going to be 2 cosine of 2x. Now, where do we get that? Well, once again, so let me go over here. So sine of 2x, let's say we're taking just the derivative of the sine of 2x, right? Since we want to take the derivative of our a prime. What is this derivative? Well, you're taking the sine of the derivative of the entire thing, and you're treating this like x. So x is equal to 2x, right? So just sine of x would get you cosine of x. Now cosine of x becomes, using x equals 2x, we get cosine of 2x. Now that we have done that, we have to take the derivative of our inside function, which we used to have as x. And taking the derivative of our inside function, which we'll now call a, well, a prime is just equal to 2. Now we get 2 cosine of 2x. So that's where this chain rule idea becomes really, really complicated. So going back to the original problem, where does this get us? Well, we know that sine of 2x is 2 cosine of 2x. We can bring the 2 out, and we'll get 10 times sine of 2x to the 4th. So you can see how the chain rule can get pretty complicated when you're using it a lot of times in a single derivative. But this is the basic idea, so if you need to, go ahead and rewatch the video and just understand how the chain rule works, especially in this example, because we'll be doing a lot of trigonometric derivatives where you need to use the chain rule.